the vertical line test in Mathematica, and here we actually have the graph of the function y equals the square root of x, so it should pass the vertical line test. So we've set this up so that we drag a line k. We're looking at the line x equals k here, and we drag it across the graph. And of course, when x is -1, -1 is not in the domain of this function, so the line doesn't cut the graph at all, but that doesn't violate the vertical line test. So there's still no problem. It still might be the graph of a function. And then as we move the line to the right, we see when it does cut the graph, it cuts the graph exactly once. So this does pass the vertical line test, at least for the window we're looking at. So we can conclude that this is the graph of a function, but of course we knew that already. Now of course when we apply the vertical line test to the graph, there's a misprint there of x squared plus y squared equals 1. As you saw in the notes, this violates the vertical line test. Outside of the interval x between -1 and 1, the line doesn't cut the graph at all, but that's not the problem. That doesn't violate the vertical line test. But you see here for x equals 0.5, then the vertical line x equals 0.5 cuts the graph twice, so most certainly this is not the graph of a function. However, the top half of the circle, which is the graph of y equals the square root of 1 minus x squared, does pass the vertical line test. And this agrees with the algebra we discussed, that when you can give a formula for y in terms of x, y equals f of x, and that gives you a unique y on the graph for every x. So every vertical line cuts this exactly once, but of course the graph of this is just the graph of one half of the circle. And the other half is given by y equals negative the square root of 1 minus x squared, and that too is the graph of a function.